And here we go with lesson 17, section 7.3. We're going to be dealing with the addition and subtraction formulas for sine, cosine, and tangent. First, we're going to start with a small point, or small topic, and that's cofunctions of complementary angles. You've actually been doing this without actually knowing it, but we're going to talk about sine and cosine are cofunctions, tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. Now, don't get this confused with reciprocals. Although tangent and cotangent are both reciprocals and cofunctions. We're talking about cofunctions on this slide and in this topic. And as a reminder, complementary angles are two acute angles whose sum is 90 degrees in the case of degree angles, or pi over 2 in the case of radian angles. And there's a lot going on here, but basically what this says is the sine of any angle is equal to the cosine of its complementary angle, or the tangent of any angle is equal to the cotangent of its complementary angle, and the same for cosecant and secant. Notice I have them written here in both radians and degrees. And you kind of already knew this, because you knew this from sine of 30 degrees was equal to cosine of 60, or that the tangent of 30 degrees was equal to the tangent of 30 degrees equals cotangent of 60 degrees. You also knew that sine and cosine of 45 degrees are equal to each other. And this is what we mean by cofunctions of complementary angles being equivalent to each other. And this is just a little cleaner version of it. It works both ways. Sine is equal to the cosine of its complementary. Cosine is equal to the sine of its complementary angle. This is a very small point of what we're talking about here. We'll do some examples though. Here we go. And you notice we have sine, cosine, sine, and cosecant represented here. And we're going to find the cofunction of their complementary angle. So you have to think of both, the cofunction and the complement of the angle. And the first one up is tangent of 23.54 degrees. Two things going on here. Its cofunction is cotangent, and the complementary angle is 66.46. And if you were to do these in your calculator, the tangent of that angle and the cotangent of the complementary angle, you would get the exact same value. The cofunctions of complementary angles are congruent to each other. And let's do it for sine. The cofunction of sine is cosine, and then 1/6, well, that would be 1/6 radians, and so we take pi over 2 minus 1/6, and common denominators, and we combine everything, we get 3 pi minus 1 over 6. Although I think your online homework will take cosine of pi over 2 minus 1/6. Go ahead and get a common denominator and combine that into one fraction. And here we go with cosine of pi over 5 radians. The cofunction is sine. 2 pi minus pi over 5 is 3 pi over 10. Although again, I think your online homework will accept pi over 5 minus pi over 2 minus pi over 5 rather. Get a common denominator, have some pride. And let's wrap up this little section here. The cosecant cofunction is secant, and pi over 2 minus 0.74 would be the complement to 0.74. And if we're asking for the exact answer, you got to stop right there. You can't use your calculator to give us an approximated value. If we ask for an approximated one, certainly you could pull your calculator out. But this is actually the exact answer. All right, let's get to the meat of this lesson, the addition and subtraction formulas for sine, cosine, and tangent. All right, well, look this over. I'll give you 1 minute and you can memorize it all. Oh, you don't have to memorize it. These are all formulas that will be given to you on the formula sheet. Therefore, you do not have to memorize them. But basically what we're looking at here is the sine, cosine, and tangent of u plus v or u minus v, where u and v are two angles that we know something about, 30, 45, 60 type angles. And so we use these addition and subtraction formulas to come up with the exact sine, cosine, or tangent for angles that we don't know about, that are combinations of the angles we do know something about. And u is simply the first angle, v is simply the second angle, and that's what we use them for. And I'm going to do a series of examples here on how we use these. You don't have to memorize these formulas. They're going to give them to you on the front page of the exam, and since they're on the formula sheet, you don't have to memorize them. So the first thing we're going to do is something that has nothing to do with the previous slide. Previous slide talked about the sine of u plus v. This is the sine of an angle plus the sine of another angle. If we know the sine of 2 pi over 3, and we know the sine of pi over 4, we can simply add those together. And you will see this at the start of every one of these problems, because we want you to know that what we're doing in this lesson is not this. So let's get the answer to this one. So we find the sine of 2 pi over 3, we get square root of 3 over 2, and we find the sine of pi over 4, and we get square root of 2 over 2, and we add those together. They have a common denominator. These should always have common denominators. And I would also note that sine and cosine of pi over 4, you're better off using square root of 2 over 2 and not 1 over square root of 2. We get those, we get square root of 3 over 2, square root of 3 plus square root of 2 all over 2. We can't combine those to make square root of 5. Please don't try that. So now we're going to do what this lesson is really all about, and we're going to find the sine of 11 pi over 12. And we really don't know anything about that, but we do know that 11 pi over 12 is equal to 2 pi over 3 plus pi over 4. And we know the sine and cosine of those two angles, and so we will use that to find the sine of 11 pi over 12. So we go back to the formula sheet, and this is the sine of u plus v. And if you go to the formula sheet, you'll see the sine of u plus v is the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. And so we just plug those values in. And then you have to actually do the sine and the cosine of these angles. So the sine of 2 pi over 3 is square root of 3 over 2, and the cosine of pi over 4 is square root of 2 over 2, and the cosine of 2 pi over 3 is negative a half, and the sine of pi over 4 is square root of 2 over 2. You'll be better off using square root of 2 over 2 than 1 over square root of 2 with sine and cosine of 45 degrees. So all we do is pop them in, and then we do math. And as I said, we just do math. And square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Negative 1 times square root of 2 is negative square root of 2. 2 times 2 is 4. And we combine those two, and again, we cannot combine square root of 6 and square root of 2. We just have to leave it as square root of 6 minus square root of 2 all over 4. But look at the answer to part A and look at the answer to part B, and you'll notice they're not the same. And then we want to stress to you on this is that you cannot distribute that sign in part B. And you can't just say, well, I found an easier way to do it. I'm just going to take the sine of the first angle and the sine of the second angle and add them up. This is not multiplication. And I'm talking about the sine of 11 pi over 12 or the sine of u plus v. You have to use the formula in order to come up with the answer on this. So our final answer is square root of 6 minus square root of 2 all over 4. That's the exact value of the sine of 11 pi over 12. And I don't know what that does for us, but it seems to make us happy. Off to our next problem. Oh, I hate tangent. You'll soon learn to hate it as well. Tangent of 30 degrees plus the tangent of 225 degrees has nothing to do with this problem. Let's prove that. So the tangent of 30 degrees is square root of 3 over 3, and the tangent of 225 is a positive 1. And again, you're better off using square root of 3 over 3 opposed to 1 over square root of 3 with the tangent of 30 degrees. Add them up. We already have it. We change 1 into 3 over 3, and we end up square root of 3 plus 3 all over 3. Now let's find the tangent of 255 degrees, which is something we don't know anything about. But we do know that it's 30 degrees plus 225 degrees. So while we don't know anything about 255 degrees, we know a lot about 30 and 225. So let's use the formula. And from the formula, again, you got to reference back to that formula sheet. It's the tangent of the first angle plus the tangent of the second angle, and then all over 1 minus the product of the two tangents. So it's the tangent of 30 plus the tangent of 225 over 1 minus tangent 30 tangent 225, and now we have to use the actual values of those tangents to finish this up. And here's a bunch of math, and you just have to take some time on this one. You might want to stall this slide and stare at it, but this is why I hate tangent. I mean, this is tangent of 30 is square root of 3 over 3. Tangent of 225 is 1. That's not bad. All over 1 minus square root of 3 over 3 times 1, and then we end up with a common denominator on the numerator of 3. Down below, I turn 1 into 3 over 3, and I multiply, and we finally end up with square root of 3 plus 3 over 3 divided by 3 minus square root of 3 over 3, and I multiply by the reciprocal of the denominator, and I get it to square root of 3 plus 3 over 3 minus square root of 3. And that's there on the right-hand side. And I think your online homework system will accept that as an answer. But let's go ahead and rationalize this. And what I mean by that is I'm going to multiply the top and the bottom by the conjugate of the denominator. And that is going to be 3 plus square root of 3 over 3 plus square root of 3. Now, when I do that, you just have to follow the math along, but then it whittles its way down to square root of 3 plus 2, and that's a much better answer. And then what I have below here is, I show you that the tangent of 255 degrees is equal to square root of 3 plus 2. And you can't distribute that tangent through the 30 and the 225. And so you actually end up with part A here, the answer was square root of 3 plus 3 all over 3. And part B, the answer was square root of 3 plus 2. Our answer is square root of 3 plus 2, but we always want to show you that you cannot distribute that tangent and try to find a quick and easy way to solve this. All right, let's go to our next problem. We're going to do cosine of pi over 12, but we always start with part A to show you that you can't do it a quick and easy by distributing. And here we go. We show the cosine of pi over 3 is 1/2. The cosine of pi over 4 is square root of 2 over 2. And this has nothing to do with this new material that's in this section. You end up with 1 minus square root of 2 over 2. Next up, though, we're going to find the cosine of pi over 12. So from the formula sheet, we want to find the cosine of pi over 12. So that's going to be the cosine of pi over 3 minus pi over 4. So if you take pi over 3 minus pi over 4, you get pi over 12. And so that's the cosine of the first angle, cosine of the second angle, plus the sine of the first angle, sine of the second angle. So notice cosine is cosine, cosine, sine, sine. And if you see a plus, then it's a minus or vice versa. Well, then we just have to find the cosine and the sine of these angles. So the cosine of pi over 3 is 1/2. The cosine of pi over 4 is square root of 2 over 2. The sine of pi over 3 is square root of 3 over 2, and the sine of pi over 4 is square root of 2 over 2. Now we do math, and we multiply, and we get square root of 2 over 4 plus the square root of 6 over 4, which we cannot combine other than the fact that they have a common denominator. And so we end up with a cosine of pi over 12 equaling square root of 2 plus square root of 6 all over 4. And now we're going to do a couple of examples the students seem to like because it's not too difficult. But here we're going to go the opposite direction. Instead of asking you for the cosine of u plus v, we're going to say, here's the cosine of 17 degrees times the cosine of 25 degrees minus the sine of 17, sine of 25 degrees. And we want you to express this as a trigonometric equation function with only one angle. So we've given you the right side of the equation, and we want you to come up with the left side. And if you look at the formula sheet, you'll notice that cosine, cosine minus sine, sine is the cosine of u plus v. And so we whittle this down to cosine of 17 degrees plus 25 degrees, which is the cosine of 42 degrees. And we did it. We expressed it as a trigonometric function of one angle. Let's do another one. I've got the sine of 25 degrees cosine 17 minus cosine 25 degrees sine 17. And we want to express this as a trig function, one trig function of one angle. So go to your formula sheet and see if you can match this up. And if you look on the formula sheet, you'll notice that sine, cosine, cosine, sine refers to one of the sine equations. And since there's a minus sign in there, it's the sine of u minus v. So sine of 25 degrees minus 17 degrees. And we end up with sine of 8 degrees, expressed as a trigonometric function of one angle. The function is sine. The one angle was 8 degrees. We did it. You hope a lot of those show up on the next exam, don't you? I know, everyone does. All right, let's wrap this lesson up with a couple examples here, although they are rather extensive. If alpha and beta are acute angles such that the tangent of alpha is given and the sine of beta is given, we're going to find the sine of alpha plus beta, the cosine of alpha plus beta, and the quadrant that contains alpha plus beta. And I'll add something else here. I also want to find the tangent of alpha plus beta, and I'll walk you through that. We can do that without actually using the formula. So let's get started on this. So the first thing we do is we notice that alpha and beta are acute angles. That means they're in quadrant 1. So we want to build the triangle up in the correct quadrant, which is quadrant 1. We also have some information about alpha. The tangent is 15 over 8, so that's opposite over adjacent, 15 over 8. And if I look at beta, the sine of beta is 12/13, that's opposite over hypotenuse. And so the only thing we're missing now is the third side, so we'll use Pythagorean theorem to find the third side. Get the triangle in the correct quadrant and get it properly labeled. That is probably 7/8 of this problem. And so with Pythagorean theorem, we get the hypotenuse on the triangle that contains alpha to be 17. And on beta, we get the adjacent side to be 5. So again, we've got the triangle properly labeled in their correct quadrant. Now we can get to work. So first we're going to tackle sine of alpha plus beta. And so we go to the formula sheet and we notice that the sine of alpha plus beta is the sine of the first angle times the cosine of the second angle plus the sine of plus the cosine of the first angle times the sine of the second angle. So I've got sine alpha, cosine beta, cosine alpha, sine beta. And then all we have to do now is go to those triangles and fill them in. And if you've taken the time to properly label the triangle, this part's rather easy because the sine of alpha is just 15/17. Just go up to that triangle. The cosine of beta is 5/13. Just go up to the triangle. And then the cosine of alpha is 8/17, and the sine of beta is 12/13. Now, if you find yourself repeating a fraction, you've probably made an error unless you happen to have very similar fractions. Then we just do the math. And when we do the math on this, we end up multiplying those out, and we get 75 over 221 plus 96 over 221, and that adds up to 171 over 221. Hey, we did it. We just found the sine of alpha plus beta. All right, next up, let's go after the cosine of alpha plus beta. And you go to the formula sheet, and that's cosine, cosine minus sine, sine. Notice the difference between sine and cosine. And also the big difference is the cosine of alpha plus beta has a negative in the equation. If you look up there at sine, the sine of alpha plus beta has a positive. So there's slight differences between the two. And again, these are going to be on the formula sheet. So we're going to do cosine alpha, cosine beta minus sine alpha, sine beta. And I'm going to use the exact same figures that we have up there that we used in part A. And we get 8/17, 5/13 minus 15/17, 12/13. Notice the common denominators always work out. And we get 40 over 221 minus 180 over 221. And that leads us to a negative 140 over 221 for our final answer on that one, cosine of alpha plus beta. Part C then said, find the quadrant containing alpha plus beta. We've got a positive sine and a negative cosine, so that should indicate to you which quadrant alpha plus beta resides in. So since the sine is positive, that has to be either quadrant 1 or 2, and the cosine is negative, which is either quadrants 2 or 3, it turns out that alpha plus beta resides in quadrant 2. I will say that if you have two acute angles and you add them up, you can't get bigger than 180. The sum had to be somewhere between 0 and 180. So quadrant 3 would have been a little tough anyway. So we ended up in quadrant 2 with this one. Now, while we're staring at all this, what's the tangent of alpha plus beta? And I don't want to do the tangent formula. But look, you've got the sine of alpha plus beta, and you've got the cosine of alpha plus beta. And remember, tangent is sine over cosine. So if we take 171 over 221 and divide it by negative 140 over 221, we'd end up with a negative 171 over 140. We can find the tangent of alpha plus beta based on the sine and the cosine of alpha plus beta. Sometimes students like to do that if the tangent formula is getting really, really nasty. They'll find the sine and the cosine and just divide the two. I don't care. It's up to you. And so here we got alpha and beta are acute angles. Cosecant alpha is given. The cotangent of beta is given. And we're going to find the sine of alpha minus beta, the tangent of alpha minus beta, and the quadrant containing alpha minus beta. And I might add, we'll be able to also use these two to find the cosine of alpha minus beta. So just like we did before, we draw the triangles in quadrant 1. We label the pieces they give us. The cosecant is 5/3, so therefore the sine would be 3/5 there on alpha. The cotangent is 24/7, that means the tangent would be 7/24 there on beta. And then we went ahead on this one and used Pythagorean theorem to fill in the third side. We've got the correct quadrant, the triangle in the correct quadrant, and it's labeled properly. Now we're ready to do the problem. So the sine of alpha minus beta is sine cosine minus cosine sine. And again, all we do is read them right off that triangle up there, both triangles up there. So the sine of alpha is 3/5. The cosine of beta is 24/25. And then minus the cosine of alpha is 4/5, and the sine of beta is 7/25. And we end up with 72 over 125 times 28 over 125, and that gives us 44 over 125. And that's not too bad, finding the sine of alpha minus beta. Next up is tangent. I hate tangent. All right, so we want to do the tangent of alpha minus beta. So that's the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha times the tangent of beta. And again, this comes straight from the formula chart. And we now have to fill in our tangents, which aren't too bad in this case because there's no radicals. It really gets nasty when there's radicals involved. So there's a bunch of math here. So the tangent of alpha is 3/4, and the tangent of beta is 7/24. So I have a minus sign between them. And on the bottom, I've got 1 plus their product. Common denominator. You could use 24 as your common denominator, but I'm going to give you a hint here. Use their product. In this case, it's 96. 4 times 24. Your life will be easier. You'll see here as we move to the right. So that's 72 minus 28 all over 96, which gives me 44 over 96 in the numerator. On the bottom, I turn 1 into 96 over 96. And even though I could have canceled some things out, I just make it, I multiply 3 times 7, get 21, 4 times 24, and get 96. So I end up with 117 over 96 on the bottom, and this is why I went ahead and stayed with 96, or the product of 4 and 24, as my common denominator, because now look, I multiply by the reciprocal, the 96 cancels out, and I'm done. And so your life will just be easier if you just go ahead and use their product as a common denominator, and you don't spend time searching around for a least common denominator. So the tangent of alpha minus beta is 24 over 117. And now we want to ask the question, what's the quadrant containing alpha minus beta? And what do we have here? We've got a positive sine, and we have a positive tangent. So what quadrant do you have a positive sine and a positive tangent? And that only happens in quadrant 1. So the alpha minus beta must stay in quadrant 1. Now I'm going to ask the question, what is the cosine of alpha minus beta? And so if you took sine divided by cosine, you would get tangent. And our sine is 44 over 125, and our tangent is 44 over 117. So think about that for a second, and hopefully you would come up with the cosine as being 117 over 125. Again, that 117 in the denominator of the tangent gives away the numerator of the cosine, and then both the sine and the cosine would have to share the same denominator, which in this case is 125. So our cosine would be 117 over 125. Even though we didn't actually do it, we based that on the sine and the tangent. Well, this concludes lesson 17. Get to work on your homework.